p.m. So we're going to go ahead and get started. My name is York Groh. I'm the Mapping Solutions Manager here at Duncan-Parnell, and want to spend some time with you today talking about hydrant pressure monitoring, but also how it's incorporated with just general remote monitoring solutions that Trimble can provide through their Trimble Water division. A couple of housekeeping things, just so you're aware, this webinar will be recorded, and then we'll make this recording available to you, and those that registered but weren't able to join, we'll make that available to you within the next couple of days or so. With me today is Marissa Body. She's with our marketing group, and she'll be kind of monitoring things on the back end. And then our main presenter is Jeff Smith, and I'll let him tell you a little bit more about himself when he takes over here in just a moment. During the main part of the webinar, if we're going to keep everyone muted, and then if you can just send any questions via the chat, we'll monitor that. But then certainly at the end, we'll have kind of an open Q&A time where we'll be glad to take verbal questions as well to entertain for Jeff that he can be able to answer. So with no further ado, Jeff, I'll hand it over to you and let you take over. Are you there, Jeff?
Yep, can you hear me?
We sure can. It's all yours.
Oh, okay. Okay, thanks. So appreciate it, York. Thanks, Marissa, and thanks for everybody for attending. My name is Jeff Smith, and I'm the Regional Business Manager for the Southeastern U.S. I'm based out of Tampa, Florida. I've been with Trimble for about 20 years, and all of that time has been in the Utilities Division, in particular the Water Division within Trimble. Today we're going to talk about hydrant pressure recording, hydrant pressure monitoring. This is one of the most popular products that Trimble has, especially in the Trimble Water Group, and I'm looking forward to talking a little bit about how it can help your organization. To get started, just real briefly, a couple of things about Trimble and Trimble Water. Trimble was founded in 1978 as an early GPS pioneer. Ever since that time, water utilities have been a main customer within all Trimble businesses. Our Trimble Water division fits within our utilities sector, utilities and public administration. That's the division within Trimble that Trimble Water sits in. And what Trimble Water is an organization where we completely make products solely for the water, wastewater, and municipal utilities industry, and all of the different types of service providers, engineers, and consultants that also work within the water utility space. Trimble Water, we work with a variety of different manufacturers of water products, such as water meters, pipes, hydrants, software solutions, and things like that within the water industry. We have about 3,000 clients throughout the United States. And they vary in size from just couple of hundred water meters and customers up to a couple of million. So our solutions are really tailored for all different sizes of utilities. This is a quick map of our location, not our locations, but our customer sites. Trimble Water is headquartered in Irvine, California. And we have production centers in Denver, Colorado, and Dayton, Ohio, and Rochester, New York. And we have some worldwide offices that support Europe and Southeast Asia as well. So what we do at Trimble Water is we deliver the basic building blocks that are needed for an intelligent utility. And these are really the 5 buckets of product groups where we build solutions. Most of you are very familiar with Trimble for mapping and data collection, and there's no difference here with Trimble Water. We build products and hardware that are tailored to collecting GPS data and building your asset inventory out in the field. We have solutions that we're going to talk a little bit about today related to mobile work order management. This is a way that you can go out into the field and be able to carry out work and be able to record what happens in the field, whether that work is changing out a water meter or mapping a fire hydrant or keeping track of time and material of how long it takes you to do certain tasks. Another one is through asset management. We've had lots of experience with asset management over the years, but most recently we acquired a very well-known company called CityWorks, and they provide some really core capabilities for asset management, work management, community engagement, and things of that nature. And then analytics and performance. This is where we make sense of all of the data that's coming into our platform so that we can quickly present it to you and present it as usable information. And then today we're going to talk about one of our remote monitoring products. So this is a very important sector of ours. This is where we can provide more intelligence to your asset inventory maps and GIS, where you can be able to get near to real-time data of how your water or wastewater or stormwater network is performing. We do that through our remote monitoring devices. And we're going to talk about one in particular today, but before we get into the hydrant pressure recorder, just a brief overview of what our remote monitoring solution looks like. So we manufacture data loggers, or they're commonly referred to as RTUs, or recording telemetry units. But we create and manufacture very intelligent data loggers that can capture information throughout your water, wastewater, stormwater. For water, we really focus on water flow, being able to calculate the volume of water flowing through a pipe at any location throughout your network. Pressure monitoring and impulse pressure detection so that you can be able to track down water hammers and things of that nature, or just being able to see what pressure is anywhere in your network. We also monitor water level, and this could be water level in a pond, an aquifer, a well, or a tank, or any type of water storage device, water storage facility. We have products for water leak detection so that you can monitor water leaks throughout your network. And all of this information flows up into our Trimble Unity platform, which I'll talk about in a moment. And then, of course, hydrant pressure. This is where we built for purpose data loggers that fit directly onto a fire hydrant. And I'll go through that in much more detail here in a few more slides. On the wastewater and stormwater side of things, we monitor rainfall, open channel flows. This could be stormwater related or wastewater related so that we can monitor exactly what the flow and level is inside of a manhole or a culvert or a drain. We have tools for monitoring water levels inside of many different types of facilities, but mainly inside of a manhole. And then we're able to capture all of the information that's occurring inside of a lift station or a water pumping station. So these are really the most common broad high-level applications where we have data collection or data logging equipment that can help you. So on to our hydrant pressure recorder. So this presentation has lots of pictures. There's a few slides for sure, but there's lots of pictures trying to describe what the product looks like. But our hydrant pressure recorders, you can see on the pictures here, they're built for purpose for a fire hydrant. And they are safe, they're NSF certified so that you can attach it directly to a fire hydrant, energize it with water, and it's able to capture very high frequency samples of water pressure at any moment in time. Now, we have two different types of data loggers as they're related to hydrant pressure recorders. We have the ability to gather data through a wire that you can connect directly to the hydrant or connect it directly to the hydrant pressure recorder and manually download data. We have all of our pressure recorders are Bluetooth enabled so that instead of a wire, you can connect directly to the hydrant pressure recorder through Bluetooth. And then we also have cellular wireless enabled hydrant pressure recorders so the information can be sent to you at your office or onto your mobile application on a phone or a tablet using cellular from Verizon or Sprint. But so we have lots of different ways. So we gather the data at the hydrant pressure recorder, but there's many different methods to be able to pull that data from the hydrant pressure recorder and put it onto a computer or be able to host it in our Trimble Unity cloud. And I'm going to talk a little bit about each one of those. The two hydrant pressure recorders that we sell are called the HPR 32A and the HPR 32IA. The difference between the two is that the HPR 32A captures standard, what we call standard pressure information. This is where it can sample up to 1 time a second and be able to capture and record that data up to 88,000 readings at any moment in time. So if you are just leaving the recorder on the hydrant for a couple of weeks or a couple of days, it can store up to 88,000 records at any moment in time before you need to go and either manually download it, or if you're using cellular, you'll never fill up the hard drive because it will actually send that information on a user-defined schedule. But it is what we call our standard pressure recorder. Then we have our HPR 32IA, and the I stands for impulse. And that means that the pressure sensor and the electronics that are built on the inside of this allows you to sample at a much higher rate. So where the HPR 32A can sample around 1 time per second, the HPR 32IA can sample up to 256 times per second. And the reason that we have this high rate of data capture is the IA is made for capturing water hammers. And water hammers and other impulse or transient events happen within a split second of time. So the electronics in the pressure sensor built into the 32IA is much more sensitive when we're able to capture that information. So depending on the application that you're trying to use, we have a product for you. Now, these hydrant pressure recorders are IP65, so they're relatively rugged, but they're not made to go underwater. They're made to be mounted above ground onto a hydrant. The pressure ranges that we offer these hydrant pressure recorders in, both the 32A and 32IA, are 100 PSI, 200 PSI, or 300 PSI. And that depends on what your normal operating pressure is. So you pick the flavor or the PSI range that you need, and we supply that. There's no price difference between 100 PSI and 300 PSI. We just for more accurate data collection, we want to make sure that the right pressure range is set up with the hydrant pressure recorder that you purchase. The battery life, so all of our remote monitoring products, I would say 99% of our remote monitoring data loggers, including this hydrant pressure recorder, are battery powered. So we have lots of intelligence built into the electronics of the data logger to get the most battery life out of a single battery. Now, these are Trimble supplied batteries. We call it our BP4. They're a lithium ion battery. They're non-rechargeable, so whenever the battery goes dead, it needs to be replaced. But the battery can last up to 5 years. But depending on how frequent that you sample and how often that, possibly if you're using the Verizon or the cellular capabilities, so if you were to sample 4 times per second and make 1 call in per day, that's 1 cellular data call a day, it can last up to 5 years. But if you want to set the recorder to sample at its highest data capture rate of 256 times per second, it usually lasts around a year. So the battery life is typically between 1 to 5 years. So this is a very long time for a piece of electronics that's working outside to last. So, but it is dependent upon how frequent or how high of resolution of data that you want to be able to capture. So everything we're going to talk about today is our HPR 32A and our 32IA. They're all Bluetooth enabled. They can be directly connected via cable, or they can be used with our cellular modem. So there's many different ways to be able to gather the data and view it and make use of it out in the field. So as an agenda, I want to go through some of the most common applications for our hydrant pressure recorders. So first of all, we're going to talk about customer pressure complaints, fire flow testing, hydrant capacity testing, CFactor testing, hydraulic model calibration, and then wireless remote monitoring. Wireless remote monitoring is really really one of the best applications for the hydrant pressure recorder, and I'll get into some of those details, but I'm going to also provide a demonstration at the end of this, and I'm going to show you our Trimble Unity remote monitoring platform to give you an idea and a feel for how you can use this hydrant pressure recorder for just being able to record pressure throughout your system. So for pressure complaints, I have this listed first because it's probably one of the most popular applications for a hydrant pressure recorder. Although the hydrant pressure recorder is built to be placed onto a hydrant, we do provide a garden hose adapter so that you're able to plug the hydrant pressure recorder into a customer's garden hose or to their water faucet on the outside of the house. Because if you're going to go, if you get a customer complaint called into your office and you need to go try to find out what's happening, the traditional method of this, using traditional like manual read gauges, it typically takes a lot of communication between the utility and the field worker and then the homeowner. But with our hydrant pressure recorder, we gather all of this information electronically, and it samples at a very high rate, and everything is time-stamped, not just with the date, but the exact time and second of what the pressure was at any moment in time. So for customer complaints, what you would use the hydrant pressure recorder for is that you would hook up the hydrant pressure recorder with a garden hose adapter to the customer's house, and you would open the water faucet as high as it can go. And then you would also connect the hydrant pressure recorder on the closest fire hydrant that is connected to the same water main line. And then you let it gather data for however long of a time that you feel like you would need to be able to get the information. This could be 10 minutes or this could be several days. We have customers that do both. So what you would do is you would hook our hydrant pressure recorder into the fire hydrant, energize it with water under pressure, and let it gather this very high accuracy data. And then at the end of the test, you're able to show, using a mobile computer out in the field, you can actually show the results to the homeowner to be able to see, what pressures that were being recorded on the utility side of things, as well as on the customer side. So this is just a quick example of a graph that would be shown to a customer, or that you would be able to see in your office and be able to email a customer, but you do have that ability to literally show a customer, this is the pressure that we saw at our on the utility side of things, and this is the pressure that we saw on the customer side of the water meter. In this graph, it's showing that there's a 20 psi difference, and this is through time. So you can see that this is from this time to this time, several different hours. And you can tell that there's a consistent 20 psi difference. So this is indicating that there's a problem on the customer side of things. And water utilities typically cover up to the water meter, and anything from the water meter to the house is the customer's responsibility. So we're able to do this, collect very high accuracy data, very visual, and it's easy to share with your customer. So that is one application, which is our customer pressure complaint. Another very popular use for our hydrant pressure recorders are doing fire flow testing. Fire flow testing is a task that typically takes multiple people. If you're using manual read gauges or chart recorders or anything like that to be able to do it, it requires at least 2 people to do a fire flow test. Well, with our hydrant pressure recorder, because it captures everything and time stamps it very accurately with the time, date, minute, and second, you're able to hook one hydrant pressure recorder up to a flow meter, to the flow hydrant, and one to the residual hydrant, energize them both with water. On the flow hydrant, which is represented here at the top, it's actually flows through a diffuser with our hydrant pressure recorder connected to that diffuser. And we're able to capture the detailed information that's needed to be able to give you the test results that you need to be able to say exactly what your residual and flow hydrants are reading and what the total flow was at any moment in time. This is the typical applications for this. I mean, not application, but end users, this could be the water utility if they're responsible for doing these flow tests, or possibly could be fire departments. We have folks in the Southeast that's either fire hydrants or water utilities or private contractors that do this work. But once again, you gather this information out in the field, it timestamps it very accurately, and you're able to see in real time how the fire flow test is going, and it records the information that's needed. And one thing to point out is that the data that we gather and the calculations that we create, the data that's created from this information that we gather, is all based on NFPA 14 and AWWA M17 guidelines. So you can make sure that the data that you're capturing meets those regulatory requirements. Now, we create the hydrant pressure recorder, but we also sell this as a kit. So we're able to sell 2 hydrant pressure recorders, a diffuser, this hard carry case, and any cables and software, and even mobile computers that you would need. So Trimble makes some very rugged, waterproof, water resistant, I'd say, tablet computers such as this Trimble T10 that can all be sold as a kit so that you can go out into the field and be able to gather this information and not have to worry about a traditional laptop getting wet or anything like that, because the Trimble T10 is very water resistant. You can see the screen outside. So this is a very nice kit. So we can either sell individually the hydrant pressure recorders, or we can sell it as a kit with a hard carry case, diffuser, and the data collection computer. So during your flow test and any type of flushing activities that you do, we have the ability to do fire hydrant capacity testing. Now, all of the water utility folks that are attending today are very familiar with the color of a hydrant bonnet and a cap. Well, these actually signify real world gallons per minute flows that are coming out of the hydrant. Well, with our hydrant pressure recorder, we're able to capture the peak flow rate so that you can apply the proper color coding onto your fire hydrant caps and bonnets. So you gather this information in the field. It's run through our Telog for Windows software program, which is running on a mobile computer. It captures the information that you need, and it ultimately provides you with the total gallons flowed. So if you're doing a flushing program, a lot of times there's problems with unaccounted for water, because if you don't have a measuring device, kind of like, not kind of, like our electronic hydrant pressure recorder, we're able to tell the total amount of gallons flowed. So instead of just saying, I'm going to leave this hydrant open for, an hour, you can actually be able to see live results. And because really all you need to do is flow 1,000 gallons, and you don't need to leave it open for an hour. But using a measuring device like our hydrant pressure recorder hooked to this, you can be able to tell exactly and be able to shut the fire hydrant off after you've come to 1,000 gallons that have escaped the hydrant. So it helps you with your unaccounted for water. And leak detection is a big thing for us, but non-revenue water and unaccounted for water is really big with Trimble Water, and this is a really nice application that will help you do that, because flowing your hydrants and flushing your hydrants is a yearly activity. Now, there's a couple of the next couple of applications are very much related to things that engineers are very interested in doing hydraulic model calibration, or being able to gather information that's related, very engineer related. So this is something that we call our CFactor testing. So within the same software where you're gathering this information, we're able to document exactly how much head loss is happening. And we do this through a calculation that's very standard in the industry called the Hazen-Williams CFactor. So this is a very manual process. It can take 3 different people to do this without an electronic means of gathering this information, because it literally requires somebody to be monitoring an upstream hydrant, a downstream hydrant, and a flow hydrant to be able to gather the correct information. Well, one person can do this with our hydrant pressure recorders, because you would install a hydrant pressure recorder on each one, on the upstream, downstream hydrant, and then on the flow hydrant, and it's automatically calculating this data. So you don't have to have somebody standing in front of a hydrant being able to record these manual pressure readings. We're able to do this electronically. It's all stored within our software, and it automatically produces the results that you need. So that is the CFactor test. And we have a workflow that's built for calculating and providing you with the right information. And then one of the last applications that are used for our hydrant pressure recorders is really a combination of everything that we talked about, whether it's CFactor testing, fire flow testing, capacity testing. All of that mashed up together provides all of the core building blocks that you need to be able to calibrate a hydraulic model, or to be able to provide your engineering consulting firm that's helping you with this, be able to provide them some very accurate data so that they can help calibrate the model. So all of this information, so some of these types of, once the data is in our software, we're able to do things like steady state analysis, extended period flow analysis, fire flow tests, CFactor tests. All of this is gathered, and that's the core information that's needed so that engineers can help to help calibrate their models. Now, the calibration itself, there's other software programs that are out there where you provide these type of inputs, that the type of data that we collect, and the software, not made by Trimble, somebody like Innovyze, they need this information, and they can help use that information to calibrate the model. Now, you might have your own copy of Innovyze and the software that's needed for that, but we have the means to gather this information, provide very accurate data so that you can help calibrate your hydraulic model. And we can export this information out. It's stored on our local computer, but it can be exported to a spreadsheet, and then we even have some custom exports that we built for certain modeling software, so that it's the exact format that you need, so it's a little bit easier to import into these other hydraulic modeling applications. And then I'm going to focus on the final application in a little bit more detail, and that's wireless remote monitoring. And what that's made for, this is an automated way to be able to monitor system pressure anywhere there's a fire hydrant. This can be at the end of your system, in the middle of your system, wherever it might be. You can set up a network of hydrant pressure recorders so that you're able to tell what system pressure are at any moment in time. Now, the nice part about this is that it requires nobody to be in the field except for the time of installation. So you install a hydrant pressure recorder, and it starts sending you data immediately. And you're able to see that information in the Trimble Unity remote monitoring application that I'm going to demonstrate at any time. So you buy this, and using the built-in cellular modem, it will start sending data so that you're able to see this information that you need. Being that it is wireless, and our hydrant pressure recorders are actually very intelligent, you can build how you want each pressure recorder to behave, and how, and that is remotely being able to set up how frequent that you want to be able to capture the data, how often you want it to be recorded, and how you want it to be presented in Trimble Unity. And you can do all of this from Trimble Unity from your office without having to make a site visit. So that's a big deal, because a lot of utilities are very large, and it takes a long time to get from one side of it to the other. So instead of having to manually go gather the data, we do have these remote capabilities to present the data to you, but also alarm you whenever there's a problem. And we can alarm based upon a problem. You configure what that problem is based upon what PSI, alarming condition could be set, and we can send you a text message and an email, or a text message and an email whenever there's a problem. And it's very easy to set up who gets those text messages, these text message alarms or email alarms, and based upon a couple of different conditions that I'll show you in a moment. We also have a built-in integration capability with CityWorks, which is the asset management system that is also a Trimble company. So if you have CityWorks, we have the ability to not only send an end user or a group of people a text message or an email of an alarm, but if you have CityWorks, we're able to automatically create a service order, a work order, or an inspection from CityWorks. And this is all very automated. So this is something where you're not having to wait for a problem to come in and then create a CityWorks work or inspection or service order to go visit something. It can happen and it can be triggered from the intelligence of the data recorder, the hydrant pressure recorder that we have in the field. So with that, well, I have one more step. I do want to show just a quick video to show you how to install a hydrant pressure recorder for remote monitoring. This is about a 2-minute video. So just take a look, and there's a lot of details that I'll tell you which steps are. But this takes you through how to install a hydrant pressure recorder. So the first step is to tighten all of the different nozzles on the hydrant. Before you open it up, you want to just make sure that all of the caps are secure and that the hydrant is completely closed. Then you remove the hose nozzle. And of course, it's very important for you to have a hydrant wrench. Then you want to flow, just briefly flow the hydrant just to get any debris or anything like that that's out of the lateral. This isn't anything that takes a very long time. You just need to flush it until it's clear. And in this case, the water is already flushed and clear. Then you close the hydrant. And you'll see the yellow hydrant pressure recorder just laying on the ground there. And after the hydrant's closed, you're going to screw the hydrant pressure recorder on. Now we use national hydrant threads, the standard national hydrant thread, but if your utility has a specific type of threading, we can custom manufacture that for you. But then you tighten up the hydrant pressure recorder and then reopen the hydrant, and you want to fully energize it with water. So when you're doing remote monitoring and you don't have anybody in the field to look after the hydrant and the hydrant pressure recorder, we sell it's optional, but we sell a security cover. It's really simple to put over the hydrant in these locking clasps. The only thing you need to provide is the lock. So it's very easy to lock this hydrant pressure recorder directly to the hydrant and not worry about it getting stolen or damaged. But really, this is for theft. So now I'm going to move over to show you Trimble Unity remote monitoring. And once again, before I get into the software demonstration, any questions that you have about the applications I've talked about so far, feel free to key those into the chat, and we'll get those answered for you. So this is Trimble Unity, and in particular, this is the Trimble Unity remote monitoring application. So Trimble Unity is a cloud-hosted app where we host your data. You own the data. This is always your data, but we host the data and we host the software application on the cloud. We also have a mobile application that runs on Windows, like a Windows laptop, an iPhone, an iPad, a Google, an Android tablet or an Android phone. We support all the major platforms, but we have a mobile application. So this, you'll see what we're looking at here is the Trimble Unity remote monitoring mobile app for Windows 10. If I had an iPad, I would simply show you that, or if I had an iPhone, but it's a little easier from a demonstration to show you the mobile app that's built for Windows 10. Going back to the web, so this is Trimble Unity Web, and whenever you log in, you're able to see the location of all the hydrant pressure recorders that you have. Not just hydrant pressure recorders, you can see all of the different types of Telog, Trimble Telog remote monitoring devices that you own. But for this demonstration, I just have our hydrant pressure recorders. But it's very simple to be able to say, show me all of the hydrant pressure recorders that I have, and then also all of the lift stations and rain gauges that I have in the system. And if I do that, you'll see that more sites appear. So it's very easy to be able to just look at the type of remote monitoring sites that you're interested in. And today, it's hydrant pressure recorder. So I'll turn off the rain gauges and lift stations and just look at my HPR sites. So when you log in, it brings you to a map of your distribution system. This is user definable of how big of a map or how zoomed in the map that you want whenever you log in. So it shows me these sites with not a symbol, but a label of each site name. So I can see that this is the Napier Settlement HPR, this is the High School Pressure HPR, this is the Hunterly Drive HPR, but I also see a list of all of the different sites. These sites on the map are color-coded by status. So what this means is a blue symbol represents a properly functioning recorder that has no problems or alarms. If there was an alarm, if one of these recorders was in an alarm state, like it noticed that there was a problem and a text message or email has been sent, this symbol would not be blue, it would be red. So if I want to take a look at a site, I would just simply click on it and it will zoom me to the site location of that hydrant pressure recorder. Now, Trimble Unity is Esri based. This is a very GIS centric application. So I'm looking at the map, and these background maps, we supply you with several that are available from ArcGIS Online, but these could be actual background maps that you supply that you might have that are unique to your organization. So like this is an aerial, and this is a different type of base map, but it's very simple to toggle between the different types of background maps. You can also turn on GIS data. So if you have GIS data, very simple to make a connection and be able to see your assets from your GIS. And all of these assets are very easy to be able to click and see the data that's supplied. We have multiple different ways you can connect to your GIS, but the one that we recommend is through a feature service connection to a web server, and this makes it a very live map behind the scenes. But to look at the data, so I can see that this is the high school pressure site. It gives me some basic information, but most importantly, it tells me the last time that it received data was at August 5th, and then the next scheduled call is at August 5th, but in an hour. So this is actually calling every hour. Most are set up to call every day, but this is very user definable, this call schedule. If I want to look at the data, I simply look at the report and it'll bring up the last 3 days of data. So that is what we call a default report. The default report is always set to the last 3 days of information. And I'll show you how you can change it because it's very simple. So this is showing me the shaded area is showing me the minimum and max pressure, but the solid red line is the average pressure. If I want to be able to see all of the time series data, I would click this button called View Table, and this shows me every record, every recording for that through the history of time, for as long as it's been installed on this particular hydrant. I can go back and look at every time interval piece of data. I can easily click this View Summary button, and for the time period from August 2nd to August 5th, from 141 to 141, it'll provide a summary. And this is showing me that the minimum pressure of 89 PSI was reached on August 3rd at 5:55 a.m. So I could probably tell that if I looked into this graph much, but this gives you a very quick view of where the minimum and then the maximum was hit on August 3rd at 10:58 p.m. And then the average is 105 psi. So that's what this is showing. This summary automatically updates if you change the interval. So I could change, instead of looking from August 2nd to August 5th, I can say, let's look at it from August 3rd to August 5th, and I could pick the time. And then whenever I do that, the summary is going to change. We have some quicker ways to do it, to where if I want to see the data for the last day, I can click this button, or for the last hour. So really simple to dive into the data. And as you click it, the summaries will change. These square boxes at the very bottom, these are showing me transient events. This particular hydrant pressure recorder is the HPR 32IA that's made for monitoring impulses and water hammers. So if I were to hover over this particular box, this shows me that there was an impulse here where the impulse started at this time and ended at this time, and it lets you know that that's the exact time, date, minute, second that an impulse occurred. But we also have this little bit better tool. This shows me that from August 3rd to August 5th, there's been 3 different impulses. And this has happened over time. There was one on August 3rd at 3, another one on the 4th at midnight, and then another one in the morning time of this morning. But if I want to take a look at the data, I would double click on it. And instead of looking at, 2 to 3 days worth of data, I'm looking at, I'm looking at literally 1 minute of data. So here was the impulse, and we gather the information of the impulse, what the pressure was before the impulse, the actual impulse itself, and then what the post-impulse pressure is. This is all very valuable. So I'm able to see this. So instead of looking at 3 days of information, I'm literally looking at from 2:16 until 2:17 p.m. This is the entire extent of the water hammer, and I'm able to see that. And then if I want to export data, I simply can hit this button and I can export it to a variety of formats. So I can print the chart, or I can print to a CSV file or to an Excel spreadsheet. Now going back to the bigger picture, if I want to be able to compare multiple sites together, this is the nice thing about this being GIS centric, is that the locations, so I can see my water network, and let's just say at the high school I noticed that there was a problem like that impulse. And if I wanted to be able to compare that to another hydrant pressure recorder that's local, I can simply hit this tool called Draw a Polygon, and I can say I want to compare these 2 sites together. And when I do that, I want to say, let's take these 2 monitoring sites, and I want to view the measurements and compare those 2 together. So I have the ability to stack multiple pressure recording sites on top of one another, so it's very easy for me to see and compare if this site that had an impulse or a water hammer at a certain time period, if it was also seen here, or what was the effect, and it can help me be able to isolate where this impulse possibly might be coming from. And then I can also look at my GIS and be able to see what type of other assets are in the area, like pumping stations and things like that, that could contribute to this impulse. You can also do this. You're not limited to the number of sites that you can compare. So I just did 2, but I could draw a polygon around all 3, and then be able to compare all 3 of those sites. And I would do that just by clicking this and then saying view the measurement, and then it would stack all 3 of those sites on top of one another. Now, we also have the ability to, let's just say the hydrant pressure, the high school pressure site. There's some other things that you can do to this that provide you some data. So I just really showed you the basic information of the pressure and being able to say, show me the default report. This will automatically bring up the data. But we can go to the actual RTU. This is our term for the piece of hardware. And if I want to change how it behaves, how it's recording data, how often that it calls in, and if I want to set alarming conditions, I can do that from my office without having to go to the field. And I would do that by hitting the edit button. And this will allow me to, right now, this is set to call every day at 1 a.m. But I could set it to call every hour or every 2 hours or whatever interval that you would like. So every hour is pretty frequent. It will chew up the battery a little bit more, but if you have a time period where you really want to keep tabs and you want it, regardless if an alarm comes in, you want to be able to get the data in more real time, you can set that from here. You can, on the channel and sensors, this is where that you can change how fast it's sampling and what the recording interval is. So if you want to bump this up to say 32 times per second because you think that will help you capture the type of impulse that you're looking for, you can easily set the sample rate and then the recording interval. And this is all handled by you. So it's really up to you how you want to be able to configure how that particular recorder gathers data. And then we have a simple tool to be able to set alarms. So if you're interested, this particular recorder has an alarm set to where if the PSI ever reaches 110 PSI or above, the North District will get a text message and email. These distribution groups can be groups of people or they can be an individual themselves, and you would see that in the list. So right now, if a high alarm of 110 PSI happens, the North District will get an email and a text message. You can also set a low alarm. So let's just say if the PSI ever drops below 35, I want Jacqueline to get an email or a text message. Or you can actually have multiple groups selected. So I had North District and Jacqueline. So very easy to be able to set who the distribution group is. So you can set low alarms, high alarms, or low alarms, and be able to set who gets notified. Now, if you do have CityWorks, which this is just our demo, but if we were connected to CityWorks right now, there would be an additional column where I can say, if a low alarm is hit, I want the North District to get a text message and email. However, I want the field operations group to get a work order or a service order. So it's very easy to add this other level of being able to get a group of people getting text messages and emails, but also being able to get automatically get service orders or work orders or inspections. And that's a high-level overview of Trimble Unity remote monitoring. So I'm going to go back to our presentation and open it up for questions. But really, this slide any questions would really come directly through the chatter, and we'll try to answer those. But we'll briefly go through a couple of programs that we have to get our products in your hand. So first of all, we have our trade-up program, trade-up, trade-in program. So if you have an existing Telog data logger, we have a program to be able to get you into the most recent, most modern, up-to-date product. But we also, if you have any existing monitoring equipment, in particular remote monitoring equipment that might be delivering data through radio communications or cellular or whatever type of existing remote monitoring equipment that you have that isn't made by Trimble, we have a program to be able to cut you a good deal to be able to get our latest and greatest tools. So that is our trade-in or trade-up program. So it's trade-up if you're an existing Telog customer and you would like to be able to upgrade to the latest technology, or if you have some existing equipment, we have a program for that. We also have what we call a remote monitoring solutions as a service. This is an annual subscription where we supply you equipment and the Trimble Unity remote monitoring software, as well as support and backup devices and many different things like that, to where we actually keep ownership of the hardware. You own the data, we own the hardware, and we basically supply it to you over a 3-year contract. However, whatever equipment that you need, you would get that in year 1, but we spread it over 3 years, and we make it a service. And we can provide you with more details on that, but it's really provides a way to be able to purchase our equipment and our software solutions as a service, as an operational expense, as opposed to a flat-out purchase, which is a capital expenditure. So we have multiple different ways for you to be able to purchase our products, and you would contact your local Duncan-Parnell rep to be able to talk to you with that and to be able to get a quote if that's something that interests you. I'm going to turn it over to York right now, and he's going to talk a little bit about some other services that Duncan-Parnell.
Okay, great. Thanks, Jeff. And we've got a couple of questions in the chat, which I'll bring up here in just a moment, and we'll unmute everyone. So if you'd like to unmute yourself and then ask a question verbally, we'd welcome that as well. But I just want to let folks know, in addition to the purchase and trade up information that Jeff has talked about, we do have some units available for rent. So that if you have a short-term project, whether you're consulting for somebody and need to monitor pressures for a period of time, or whether you're managing your own utility, and it would be helpful just for a short period of time to monitor some sites, we have some of these units available to be rented to you as well. So wanted to make sure that's available. But Jeff, we got a couple of questions here. Somebody asked about the cover that goes over top of the HPR, and if there are any plans to update that. The person was suggesting that just a pair of bolt cutters could easily cut through and then steal that device. So any plans to make that a different cover?
Not that I know of. It's definitely come up before, but no, there's no plans to update the security cover at this time. However, if anything happens, we're definitely going to alert our users, because it sounds like you're a user, and but there's no concrete plans to have an update for that cover. But we definitely welcome any suggestions that you have, because we're always taking that and putting that into our product plan. So unfortunately, we don't at this particular time.
Okay. And then somebody has a question about the pricing of Unity connected to the remote monitoring. But then along with that pricing question, what's the minimum requirement to be able to have the capability to email different users based on getting access to the pressures like you showed in the graphic there?
Sure. So Trimble Unity is priced at $240 per year per device. So per site. So every hydrant pressure recorder that you would purchase would also require a $240 subscription per year, and it's renewed annually. And we supply you with the number of users that you need. So it's not priced, Trimble Unity Remote Monitoring isn't priced on the user, it's priced upon the site. We'll provide access to the number of users that you need. You just tell us how many users you need access to this, and we'll provide that for you. So we don't price that by the user, it's by the site. So you could buy a single site and have all the functionality that I showed you, including the alarming capabilities and text message and emails. That's all included in the $240 per year. Now, if you're doing text messages and emails and you're getting this remotely, of course, all of the cellular communication of the phone or your laptop is on the utility. But to be able to access this data, to provide user licenses so they have access to this site that I showed, that's all included in the $240 per year. So it's a direct relationship to the number of recorders that you purchase.
Okay, great, thank you. All right, let's pause for a moment. Anybody want to chat in another question or ask a question verbally of Jeff? Okay, had another question pop in through the chat window. The data that you collect there in Unity, is there a way to incorporate that with SCADA or to make a link to SCADA? Yes.
So Trimble Unity, so the architecture of Unity and our pressure in any of our recorders is that the data goes through cellular wireless to the Trimble Unity, and that's the application that I just showed you. This is a cloud-hosted solution by Trimble. If you want that information to go to SCADA, we have what's called our Trimble Unity API, Historian API, which opens up the door and can be able to send that data to your SCADA platform. And that's an additional subscription on top of the $240 per year. But if you want that, just contact us and we'll help you out. It's $2,500 per year.
Okay, thank you. Let's see, question on doing flow tests. When you're doing a flow test with the pressure recorder, what's your sample and record rate that's recommended?
Well, we have in the solution itself. So what's recommended? We have several different default parameters that you can select from. So it's all user definable. So every system's a little bit different. They operate on different pressure ranges, you know, but it can fit whatever that whatever your sample rate and recording interval that you need. So there isn't just a one catch-all recommended. Now, when you buy this and you have the software, you have access to our tech support, and you talk to them about your details, and they can recommend something. But we really let the user choose that. But we have a lot of different default configurations for you, depending on how your network is built, and what the local pipe sizes and pressures are and things like that. But you can definitely change that with just a few clicks of the button.
Okay, great, thank you. And to kind of highlight something Jeff alluded to, there is a number of tech support people that are very knowledgeable on how not only the HPRs work, but how to monitor pressure in your system. But we also provide training. So there are folks, there's some trainers within the Trimble Telog group that can certainly provide remote training or come on site to do training as well. So we have that capability to make certain that what you implement is going to be productive for your purpose. Great. Any other questions here? All right, great. Well, I appreciate your time this afternoon, Jeff, and for those who attended, thank you. We will, as I mentioned at the beginning of this, we'll get this recording out to you that's attended, just so if you want to back up to be able to hear it again or pass it on to someone else who wasn't able to attend. But we certainly thank you, Jeff, and thanks to everyone who attended today.
Thank you very much, and have a good day.